For Competency 4 Boot Camp. My name is Deanna Schwope. I am an academic advisor here in the College of Education at USF. My background was in teaching math, so I lead these boot camps. This is the fourth of 4 boot camps. If you haven't already watched the first 3, you may want to review them slightly. Definitely go back to the first one and review the beginning where I talk about the different parts of the tests that you can be expecting to see, like the test preparation guide, your calculator, things like that. As always, if you have any questions for me, my email address is here on the screen. Take note of that. I'm happy to answer any emails that you have, any questions you have regarding the test. This document we are going to be continuing with. This is the GKT math practice document. If you've been with me for the other 3 boot camps, you already have this and we've been working on it. If this is your first one, I would pause the video and get this document out so that you have it and you can use it while we work on this part of the test. The test did change as of January 2024, so that's why you're watching these new videos, and you'll notice that the percentage of the section for Competency 4 has gone down significantly. It was about 33% before, now it's 20%. So this section did change. We did remove some parts and add some other places on the test. So just keep that in mind. So this Competency 4, knowledge of probability, statistics, and data interpretation. So we're going to be looking at a lot of graphs, charts, things like that, getting into mean, median, mode, range, things like that. So Competency 4 Skill 1, identify and interpret numerical and categorical data presented in various forms. For instance, histograms, circle graphs, scatter plots, two-way tables to solve problems. So here we have a graph. Following graph shows the number of 8th through 10th grade students at Sierra School. Based on the graph, how many students are sophomores? We know that sophomores are 10th grade, so we have to see what is this? First thing you're going to want to do is figure out what is the scale of the graph. So how much is this going up by each time? So if I take 200 and divide it by 1, 2, 3, 4, 5, I get 40. So it is going up by 40 every time. Let me get my calculator ready for any future ones. So if we come up here, this would be 440, this would be 480, that would be 520. So the answer is 520. So just make sure that you're figuring out what the scale of the graph is so you can be answering the questions based on what you see. 65, the following table shows the amount of time it takes to feel relief from bug bites when taking baking soda or ammonia, when baking soda or ammonia is used topically. Based on the graph, which of the following statements are true? Baking soda, it looks like, took for ant bites 5 minutes to feel better, 10 minutes for tick bites. Ammonia took 5 minutes for ant bites, 7 minutes for tick bites. So based on relief, the smaller the number, the amount of time, the faster, the better it is, essentially. So let's look at what we have. Baking soda is most effective for treating ant bites and tick bites. All right, so we'll just look at that. Baking soda is most effective for treating all bug bites. Now I'm going to go ahead and say no on this because we only know about ant bites and tick bites. So we're not going to say 2. So anything with 2 is not going to be correct. Ammonia is effective for treating all bug bites. Same thing. We don't know anything about all bug bites. So anything with 3 is also incorrect. Ammonia is more effective than baking soda for treating tick bites. So now let's look at what we know. So ammonia is more effective than baking soda for treating tick bites. So tick bites, ammonia is true, more effective. So the answer is B, number 4. So notice how I canceled things out. That's important for you to get used to doing, especially on any multiple choice test. Cancel them out as you go. That way you're not just constantly looking at what it is over and over and over again. Next section, Competency 4 Skill 2, analyze and evaluate how the presentation of data, example, scaling, chosen form, or selection of statistics, mean, median, mode, can lead to different or inappropriate interpretations in real-world contexts. So, a couple suggestions I have. Make sure you're comparing the units. Make sure you're making sure the units are the same. So like, for instance, are all the units in feet or all the units in inches? I had an example one time. 3 of the 4 items were in pounds and the last was in kilograms. So make sure you're taking note of the units. Also, make sure you're looking at the X and Y axis to make sure what the scale is. We kind of did that in the 2 ones before now. Always check whether the X-axis starts at 0. That's important. And look for outliers in the data. An outlier is a data value that is either extremely high or extremely low in comparison to the other data. Outliers affect the mean. So I want you to remember that. This is something that you probably need to memorize. Outliers, if they're there, they affect the mean. Data may be skewed in one very large or very small outlier. For instance, think about grades. If you had, relatively good grades, you're getting A's and B's, and then you don't turn something in, that 0 is an outlier, and it's going to pull your grade way down. And it happens the other direction as well. So just keep an eye out for outliers. All right, number 66. A consultant uses the following graph to justify why air conditioning costs were higher in 2014 than 2015. What aspect of the graph makes it misleading? All right, so we just take a note of the X and Y axis. We're talking about number of days, temperature above 80 degrees, and then the year. The bars are different heights. Well, that is true, but that doesn't make it misleading. That's just the data. The vertical axis does not start at 0. That's interesting. Let's look at the other ones just to see. The scale on the horizontal axis is too low or too large. It's dates. That's not really a scale. And then increments in the vertical axis are not equal. Untrue. So the answer is B. It does not start at 0. Notice it goes straight to 50, 51, 52, 53. So it doesn't start at 0, so that makes it misleading. Number 66, a set of data has a very small outlier. So remember, like I was saying before, like the 0, which measure of central tendency will this affect and how it will be affected? Well, we know it's going to be the mean. And because it's a small outlier, it will be lower. Competency 4, skill 3, moving right along. Calculate and interpret the meaning of measures of central tendency, for instance, mean, median, mode, and variability, range and standard deviation in real world or abstract contexts from numerical and categorical data sets. A lot of words. Basically, understanding mean, median, mode, range, standard deviation. So the 4 areas of central tendency: average is the mean, so the middle, or so adding up the numbers, dividing by how many there are. The median is the middle number, so making sure you're putting them in order from least to greatest and finding the middle. The mode is the one that occurs the most, so it's not the greatest, it's the one that occurs the most. The range is the difference between the smallest and the largest. And then in terms of standard deviation, you need to understand what standard deviation means and kind of how that interprets the spread of data versus necessarily understanding how to calculate. So we're not calculating things like variance on standard deviation. So just understanding, like on a normal distribution curve, the mean is the middle, and then you've got 1 standard deviation, and then you've got 2 standard deviations, and then you've got 3 standard deviations in a normal distribution curve. So understanding that standard deviation tells you how spread is the data from the average. So a lower standard deviation, so like a standard deviation of 1, for instance, means it's pretty close to the mean. It's all kind of right next to the average. A higher standard deviation, so like a standard deviation of 3, means almost the entire graph in a normal distribution curve. So just being able to understand what standard deviation is. Also understanding that if you add or subtract a constant, so the same number from scores, it does not change the standard deviation. So if I say the average is 100 and everything's going up by 5, everything in that entire graph shifts. So it's not going to change the standard deviation. Everything is still the same relative to the mean. So it does not change the standard deviation. So for instance, if everyone at a particular job receives a $1,000 increase in their salary, the range is going to change because everything's shifted up. The median is going to change because the numbers are changed. The mean will change, but the standard deviation will stay the same. All right, so let's go into some of these with practice. Which of the following does not have a mode of 45? All right, well, let's look at it. The mode is 45, so that one's okay. The mode is also 45, so that one's okay. The mode is also 45, so that one's okay. In this one, the mode is actually 30. Don't get yourself caught with, I'm just looking for 45. Looking for the mode. So in that case, the mode is 30. So the answer is D. All right, 69. Use the following frequency table to find the mean, median, mode, and range of the data. So we're going to do some calculations here. So I'm going to pull out my calculator. So I made this problem so you could understand a frequency table and kind of how to use it to calculate these things and how to read it. So basically, if you're looking at the frequency table, you've got scores from 1 to 5. And they're saying a 1 happened twice, a 2 happened 5 times, a 3 happened 4 times, and so forth. So if you wanted, you could actually just write them out. Like if we're going to calculate the median, we could write them out. So you'd have 1, 1, and then 2, 5 times, and then 3, 4 times, and then 4, 2 times, and then 5 once. And we can quickly add up the columns. So 2 plus 5 plus 4 plus 2 plus 1. So there should be 14 items total. So just keep that in mind. Okay, so then when we cancel it out to find the median, I'm just going to cancel a couple at a time. 2, 1, 2. Oops, shouldn't have done that one. Hold on a second. Got ahead of myself. So the median, let's see, 1, 2, 3, 4, 5, 6, 1, 2, 3. Okay, the median is in between the median is in between 2 and 3. So basically we're finding the average of 2 and 3, which you know is right in the middle of it. So it's a 2.5. But if you had larger numbers, you would go 2 plus 3 divided by 2, which is 5 divided by 2, which is 2.5. All right, so we've got the median. The mean, you could just go and add all of those up. You can also use the frequency table to kind of tell you, if I put like a multiplication sign, if the score have 1 happened 2 times, that is 1 times 2 is 2, 2 times 5 is 10, 3 times 4 is 12, 4 times 2 is 8, 5 times 1 is 5. If I add them up, I get 37. And I already said that there are 14 of them. So if I go 37 divided by 14, so this is, we're finding the median, it comes out to 2.64. Or sorry, the mean, 2.64. The mode, so the one that happens the most, frequency of 5, the mode is 2. And the range is just the largest, which is 1, or sorry, 5 minus 1. So the range is 4. So just using the frequency table to find the data. And again, you can go right back to that first thing I did here, which was write them all out, and you could just use that list of numbers if you want, if it messes you up looking at a frequency table. All right, number 70 is talking about the same data, but what we're doing is we want to know what changes, what measures of central tendency, so mean, median, mode, and range, change if 1 more 5 and 2 more 3s are added. So we could actually make another chart if we wanted. So I could make the chart with the new ones in it. So again, what we just did, and I'll put it in a different color so I remember, is 1 more 5. So 5 actually became 2 5s and 2 more 3s. So 3 actually became 6 3s. And then the other ones all stayed the same. So there's still 2 of those, 5 of those, and 2 of those. So now, same thing, you could write them all out. So we've got 1, 1, we've got 5 2s, we've got 6 3s, we've got 2 4s, get myself all messed up, and 2 5s. So again, we're going to write out our words: mean, median, mode, range. Range really quickly stayed the same, so the range is still 4. The mode changed to 3. So the mode changed. The median, let's just see. We've got, actually, let's count really quickly how many numbers we have. We have 17. So there's 17 numbers total. So let's just go one. I'll do 3 at a time at first. Okay, and as I get closer, I'll just do 1 at a time. So the median changed to 3. And I imagine the mean's going to change because we've added something else. I added these previously, and it was 48 divided by 17, which comes out to 2.82. So 3 of the 4 changed when I added additional items. All right, 71. If the company would like to give the impression that its employees are highly paid, which salary statistics should it use? So let's just look at it. Remember what I told you guys about outliers. If you look here, we've got a pretty big outlier here. We've got an outlier for the president and an outlier for the foreperson. And those are most likely going to skew the average much higher. So if they advertise, everybody averages this much pay, it's probably going to be something with the outlier. I calculated these previously. So the minimum is 15, mode is 15, median is actually 15. With the outliers, the average is 40,000. So they could say we have an average salary of 40,000, but if you look at that, most people make way less than that. So just help yourself out. If you're looking for things with outliers, it probably has something to do with the mean. Okay, your professor gives you the option to choose one measure of central tendency to represent your final grade in the class. You earned the following scores in your class exams. You have a 94, a 68, an 82, an 88, and an 82. You can already see that there is an outlier, but let's just go ahead and calculate them. You could probably, oops, forgot 68 at the beginning. You could probably reason through and just say outlier if you're running out of time, but we can actually calculate them if you want. So the median is 82. The mean, I previously added these up and did it, is 82.5. If I remove that 68, my mean is actually 86.5. And the mode we know is 82. So, like I said, outlier is going to affect the mean. Which of the highest measures of central tendency is the following set of data? So same kind of thing. We can just write them out. 20, 35, there's 3 50s and a 65. If you cancel them out, your median is 50. I calculated this one already before. The mean is actually 45. The mode is 50, so the answer is D, both B and C. Out of 30 students, 1 scores 70, 5 score 90, and the rest score 80. Which of the following measures of central tendency has the highest value? So basically, you have basically a frequency table. So you have a 70, an 80, and a 90. And you've got 1 person with a 70, 5 people with a 90. If there are 30 students, that means 24 people scored an 80. So you can probably already guess if I wrote all of this out, if I wrote 70 and then 80 24 times and then 95 times, the median is going to be 80. If I add them up and divide, the mean is actually 81.3. That 90 brings it up just slightly. The mode is 80 and the range is 20. So which measure has the highest value? In this case, again, it is the mean. Okay, 75 and 76 are talking about what I was showing you before with that normal distribution curve. Remember I said the mean is in the middle. And if you need some help on this, just Google, how do you find standard deviation? Or you find a YouTube video on standard deviation. So 400 students took a test and the mean was 100. So remember I said one standard deviation is the same in either direction. And I even gave you that in normal distribution, 68% of the data is within that one standard deviation. So 400 students took the test. The mean was 100. So I'm going to write it in a different color. So the mean is 100. And when we talk about standard deviation, what that means is it's minus 10 that way and plus 10 that way. So the data ranged from 90 to 110, and they told you that. So them just giving you that information, what they're saying is all of this data was within the one standard deviation. So they're just letting you know that you know the boundaries of that standard deviation. So basically all you have to do is find 68% of 400. And we can change a percent to a decimal by 0.68 times 400, and that comes out to 272. 76 is the same thing. Tests were given, average score was 50 points. So that's that middle with a standard deviation of 15. So minus 15 one way, plus 15 the other. So that means we have a range of 35 to 65, which is what they told us. And that, again, we know is 68%. So 68% of 700, change it to a decimal and multiply, and you get 476. All right, next. Teacher salaries range from 41,000 to 65,000. If the union negotiates a flat raise of $1,000 for each teacher, and this was I was talking about earlier in the notes, which of the following statements will be true? The mean, median, and standard deviation do not change. Not true. Absolutely, the mean and the median are going to change because you're going now from 41 to 66. So all those numbers are going to shift up. The mean and median do not change. Not true. They do change. The mean, mode, and median do not change. Not true. They do. The mean, median, and mode increase by 1,000, but the standard deviation does not change. So D. Remember what I said before. It's a normal distribution curve. The curve is still moving exactly the same. If everything went up by the exact same amount, everything is still relative to the median, or sorry, the mean in the exact same way. So the standard deviation does not change, but the others do. All right, competency 4 skill 4, solve and interpret real world problems involving probability using counting procedures, tables, and tree diagrams. So just some vocabulary. Tree diagrams are helpful if you need to list all the outcomes. So like number 78, this is a tree diagram. So Dante tossed 3 coins, use this diagram to find the probability that exactly 2 will land on heads. So we notice that it's helpful because it shows us how many outcomes there are. And you can then analyze the outcomes. And we'll get to that in just a second. The fundamental counting principle is used if you only need to know how many outcomes there are. So they want to know how many sandwiches combinations can be made if you have certain number of bread, certain number of cheese, certain number of meat. So you multiply the number of choices for the first by the second, by the third, and so forth. And probability is the number of favorable outcomes over the total number of outcomes. So let's go back to number 78. He tossed 3 coins, use the tree diagram to find the probability that exactly 2 will land on heads. So only 2. So this one has 2, this one has 2, This one has 2. The one that has all 3 heads is not exactly 2. So we have a probability of 2 heads is 3 of them out of 8. So 3/8. All right, 79. How many different combinations are there if you flip a coin, roll a 6-sided die, and then flip another coin? So this is the counting principle. So basically we're knowing you're multiplying how many choices for the first times how many choices for the second times how many choices for the third and so forth if there were more. So if you flip a coin, there are 2 choices. If you roll a 6-sided die, there are 6. If you flip another coin, there are 2. If you multiply those, there are 24 different combinations. Number 80, how many different sundaes can you make with ice cream? 3 ice cream choices, 3 choices of topping, and 2 choices for either nuts or sprinkles. There are 18. So again, that is the fundamental counting principle. All right, number 81, you have 4 items. How many ways can you choose 2 items if the choices cannot be repeated? Sometimes, like I said, it's easier just to write them all out. So what if you had A, B, C, and D? And you can choose 2 without repeating, okay? You could have A, B, A, C, A, D. BA is already used because we had AB, so then we could start with BC, BD. CA is already used, CB is already used, so we have CD, and then D has been used with all of them, so there are 6. All right, 82 and 83 are dealing with probability, compound probabilities. It is the probability of the first times the probability of the second. So we have a bag containing 12 red marbles, 8 blue marbles, and 4 green marbles. What is the probability you pick a red marble and then a green without replacement? And you'll notice in this one, it says with replacement. There are 24 marbles in here. So basically it is the probability of a red times the probability of a green. All right, so probability of red, we had 12 red out of 24. And remember we said without replacement. So we still have 4 green, but we did not replace the one that we pulled out. So now we only have 23. If you multiply those together, it comes out to 48, 552. If you want to simplify, it comes out to 2/23. All right, look, it's 83. It's the same problem, but the only difference is we did replace. So you're going to see that the denominator does not change. So it's still 12 out of 24. Then we have we put that one back in, so 4 out of 24 again, which comes out to 48 again, 5/76, which is 1/12. You could find them in decimal form just to see what the comparison. It's a slightly better probability in number 82 than 83 because you have one less to choose from to get your green in the second pull, but very slight. So just knowing how to do compound probabilities like this and understanding with replacement and without. All right, last concept. How many ways can 4 children finish a race if there cannot be a tie? So this is kind of like the counting principle, but what it is once you've chosen one, it can't be chosen again. So it's like, how many ways can you put some? So number 85 is the same thing. How many ways can you put 5 books in order on a screen? So 1, 2, 3, 4 on a bookshelf. 1, 2, 3, 4, 5. So the first one, number 84, 4 children. Once one of them finishes, there's 4 options for first place. Once one of those finishes first, you only have 3 options for second. You only have 2 options for third and 1 option for fourth. If you multiply those together, it comes out to 24. This is also sometimes written like this as 4 factorial, which just means 4 times every number smaller than it. 85, like I said, same thing. You have 5 books to choose from the first, then 4 for the second, 3 for the third, 2 for the fourth, and 1, and that comes out to 120. And you'll notice the next page is just 3 pages really of the answer choices. So I, again, Thank you for coming. Thank you for joining me. This competency, like I said, went down to 20%, so it was significantly shorter than it used to be. As always, here is my email address. If you have any questions, please get a hold of me. I'm happy to help you throughout your journey and so you get ready for your GKT. And thanks again for joining me. As like I said, good luck. Let me know when you pass. Have a good one.